So the question says on a kernel, it's under linear algebra. Find the kernel of the transformation T such that R2 maps to R3 represented by T of x1, x2 equals x1 minus 2 x2, 0, negative x1. So this question is very straightforward. First of all, you will say T of x1, then comma x2 like this, then it should be equated to this which is here up. So we'll say, let me zoom the camera, we'll say x1 minus 2 x2, 0, negative x1 like that. And then everything should be, since you've seen that there is this part and this part kapakati akana iri ku last part, so say should be equal to 0, 0, then 0 like that. Then from there we arrange to say x1 minus 2x2, this part here should be equal to this first 0. Again, this part 0 should be equal to the second part. So here we have 0 equals, then the last part, this part, negative x1 should be equal to what? Also 0. Then from there, you have just finding the value of what? Of x. So you know to say negative x1 equals 0. So when you divide throughout the negative, we have x1 equals 0 like this. Then you go to find the x2. So you say if x1 minus 2 x2 equals 0, you know what is on x1. So what is on x1 is 0 minus 2x2 should be equal to what? 0. From there, you just divide now to say negative 2 x2 equals 0. So you divide throughout. Negative 2, negative 2. So even your x2 equals what? 0. So from there, if you know that even your x2 is equals to 0, then you define the kernel. So you say kernel, the kernel of T equals, in bracket, your first x1 was 0, 0. Just like that. So therefore, this is your answer.